Hello, and I want to welcome you to a discussion on 6.6 linear inequalities. So let's get started. First of all, in your notes you'll see that you see symbols of using inequalities. There are four different types you'll see. And first of all, I just want to get started and just put in some different values for how to use inequalities properly. So with number 1, you could say something like 4 is less than 5. With 2, you could even say that 5 is greater than negative 9. With 3, you could say something like negative 1 is greater than negative 5. With number 4, I like to say 3 is less than 9. Number 5, since we have this attached equals to, that reads blank is greater than or equal to 9, or blank, excuse me. So what I like to say is negative 9 and negative 9, because that means negative 9 is greater than or equal to negative 9. With 6, you could read that as 0 is greater than or equal to negative 1. Again, with number 7, you could do something like we did with number 5 and say 4 is less than or equal to 4. And finally, with something like number 8, you could do something like negative 8 is less than or equal to 28. Less thans do not automatically mean that they have to be the same. It just means that the inequality has to make sense. Okay, so let's start off by looking at how to graph. If we just have a less than or greater than, if they just look like this, that means you're going to have an open dot over the whatever the value is equal to. If you have less than or equal to or greater than or equal to that look like these, that means you're going to have solid dot. So looking at number 1, we have x is greater than 4. Alrighty, so since we have no equal to found there, we will have an open dot. So go to 4, place an open dot, and if x is, or the variable is located on the left side of the inequality and it is alone with just the coefficient of 1 as present from example 1 right here, whatever direction the inequality is pointing, you can think of that as an arrow, and it's telling you to go in the direction the arrow is pointing. Or you can think of it in terms of what values would make this inequality true. 5 would make the inequality true, 6 would make it true, 7 because these values going in this positive direction are greater than 4. Looking at number 2, x is less than negative 3. Since there are no equal to, let's put an open circle found on negative 3. Okay, and just as before, you can think of this as an arrow pointing you in the direction. The inequality looks like this since the variable is found on the left side, so it's telling you to go in that direction. Or just think of it in terms of what values will make the inequality true. What values will happen whenever a negative 3 is larger? That's going to be anything that's larger than negative or smaller than negative 3, or just keep going down this negative scale. Okay, with number 4 we have our first equal to. So that means we're going to have a solid dot, and that looks like 8. So let's put a solid dot on 8. And again, since our inequality is pointing this direction and the variable is found on the left side of the inequality, think of it as an arrow pointing you in the direction. And finally, example 4 for this set. We have just a plain greater than at negative 7, so we just put an open circle. Inequality is pointing to this direction of the number line, and since the x is on the left side, we can think of it as an arrow pointing us in the direction that we need to go. And that is how you would work with these. kind of simple inequalities where it's just simply graphing. Okay, here are the steps of addition property of inequalities and multiplication properties of inequalities. You may stop the video to read or refer to your notes or your textbook. But the most important thing that you can see will be from the multiplication property and the positive and negative. Positive will work a lot similar as the addition property, except whenever there's a negative. When you divide by a negative, you will have to flip the sign of the inequality, and we're going to see some examples of this in just a few minutes. Looking at example 1, we see x plus 7 is greater than or equal to 20. So you can just think of this as a regular equation, and we have to solve for that x here. So to do that, we start working away from the variable, so we have to subtract 7 on both sides. X is, and actually let's make this a 17. This should be a 17. That was a mess up in the notes. So bring down our equality because we have not divided by a negative. So we have 20 less than 17, or subtracting 17, so that means x is greater than or equal to 3. Since we have that equals 2 in there, we can put a solid dot, and since the variable is from the left side of the inequality, we can think of it as an arrow pointing us in the direction we need to fill in. Okay, with number 2, we have x minus 8 is less than negative 16. So what can we do to get x by itself? We can add 8 on both sides. Bring down our variable x since we did not touch it. Bring down the inequality of less than, and we have negative 16 plus 8 is negative 8. Graphing that, we have no equal to, so we'll have just a plain open circle. We have the inequality with the variable facing the left side, so we can think of that as a map or an arrow telling us where to circle or color in on the graph. Okay, our next example, and probably the last one for this video, will look something like this, where we're using the division property. We have to use the division property. We want to check the sign of the inequality. So we have 4x is greater than or equal to 12. For this, as you see, 4 times x. We have to get x by itself by doing the opposite property. So we have to divide by 4 on both sides. So divide by 4 on both sides of the inequality. The 4's will cancel out on the left side, leaving you with just x. Now with our rule of inequality, anytime you divide by a negative value across the inequality, you have to swap the signs. Since we're dividing by a positive, we do not have to change the sign. In fact, we do not want to. So we just leave the sign of the inequality facing its direction the way it is. So we have 12 divided by 4, or just 3. So 12 is greater than or equal to 3. We have that equal to attached to the inequality, so we put a bold colored in circle over 3. Now we have the inequality with x facing the left side, so that means we can think of it as an arrow. You can actually think of it as an arrow telling you what direction to color in on the graph. Okay, this will conclude the examples found on this video for part 1. Part 2 will pick up where we left off with set 4.